Okay, I've been wasting some more time on my mock-up motor, so the stupid comments is, yes, it will run, yes, it's going to get raced, and yes, it's going to take a while to make it. No shit. So there you go. And why am I doing it? Because I like to. That's why I'm doing it. Alright, so this is what we got right now. We got the twin rear head on here. I've canted the heads a little bit, so that means they're not straight on the motor right now. See how it's turned? And that's going to help our push rod angle a little bit here, going up, so it's more straight on these two of these. So I think that's about close to the best angle, but maybe just a little bit more that way. But something like that. We're going to have two pan D-rings stuck in here to get the height of the head up high enough to see with. I mean, for the ports. That's what I want to do. And so that's what I was looking at. And then the I got Evo blocks stuck in here instead of the shovel head blocks. So that allows me to straighten out the push rod angle a little bit on this one here. The disadvantage is I have to use an Evo cam. The plus of it, it's got through push rod oiling to your top end, so you don't have to worry about external oil lines and shit like that, which is a good thing. So that makes it a little bit easier. So, and these are the old cast iron blocks that they were around back in the 90s off and on through the years and late 80s. So they used them all different years and stuff, so Harley used these whenever they wanted to. So these are cast iron, so these are basically will not really wear out. You don't have to worry about them breaking, that's for sure. Alright, so basic, I'm kind of looking like something like this here. And the port design I want to use is over here. So this is a NASCAR head, RCR, I think was what it was. GM Racing. I can't remember what the name of it was at the time, but anyway, this is about a 10-year-old head, I guess, nowadays, but I've had it for a while. Is that a casting date, 10/07? Whatever. Some racing guy will tell me what that part number means. And there's some other numbers over there, means something else. I don't care. So anyway, these are the ports I like. See how the ports kind of go in there? They come up high, they got a very, very tall valve, which is, these ones are right here. So this head has the smallest valves they used in it. These are 6mm stems instead of 7, or 5/16. So these are the small ones. So they go in there like this, see? So when you put these into your Harley, see why this got grown up? It goes up in here like this. You put this valve at about right here is where I want that valve to be, something about right in that angle. Probably a little bit flatter though, about like that angle, up to about there. And you're going to put a rocker arm up on top, and you can see why we need all this height now. And you can also see that the port will no longer be down here, it will be coming out of this area up here is where the port's going to be coming out of. And instead of being an angle like that, it's probably going to be more flatter, about an angle like this coming out to duplicate what they got going on here. So that's a slightly upward angle coming off to 90. You can remember my 90 is over here, so their angle is coming out about an angle like this probably. So that means the port would come out about an angle like this, and I got to come down like this for a carburetor coming out here. And of course the carb we're going to use is a D carburetor. In case you know what a D is, that's big boy. Same one I use in my single, see, big boy man carb. So I want the carburetor to be over here someplace, about in here, this area. So when it's tucked in on the bike, it'll be somewhere about over here. So aerodynamically, it won't be too awful bad. And I have to come back about here. So the man with the port will be way coming out of here. You have to make a rounded port to this. And something about this area here. So that's where it would sit. And the one on the other side would be coming out this other side. It'd be like over here someplace, probably about right here, up high. So that would be facing forward, which gives you a nice good ram air. I like that. This one here, the manifold is, or the carb's pointing the wrong direction. So I'm not sure whether you run the stack on here, velocity stack, and just run a big air box in here with the air down in here to come in, and just have a big box, or do you take a stack like this and make a big U and go down here and make it progressively bigger as you come around, because air doesn't like being straight, it wants to be moving. So either getting bigger or getting smaller, one of the two. So we'll make it bigger. So if I make a stack, the progressively gets bigger as you come around, and have it suck right down in here, the air coming down, down the bike this way. Give you good ram air to it. So it's either that or an air box, and I don't know which one's going to work. So maybe someone has a better idea on that. You have to suck it into a big air box, and you want to have the bill on the end of it to make it straight. So I don't know which way to go. I'm thinking probably do the ram horn thing that gets progressively bigger, but I don't know. Anyway, those are the carbs, and for now we run the small carb, which is the D on this one, and then the bigger motors will start opening these things up. On the 120 motor, I'll probably take one of these and bore it out to make it a Super D, which basically means you take the venturi that's in there and you cut it out. That's that step part right in there, and bore that sucker out. And then it becomes a Super D. And then for the real big motor, I'll probably have to make my own carburetor because I'd have to run 2 of these, and I don't want to run 2 carburetors, so on each side that'd be 4. I think I'll just make one. Just make it bigger. Just copy it, make it bigger. So there you go. Now the exhaust ports over here are really nice. I like these. Once again, you got a nice tall valve. And it comes straight out here, and this here height is about the same as this height. And this height here is just under the height of here. So basically this edge here is this edge about here where this O-ring is at. So that's why they had it so tall right here. It has to be that tall here too, see? That's why you gotta put a double D ring of height in there. So we'll make that work. And I haven't decided if I want to make this out of billet, cut out a piece of billet material and weld it to the head, or just weld. I don't know how to heat treat material after you weld it, because when you weld billet material, it turns into crap, soft, gummy junk. So I don't know how to make it hard again. I don't know if you throw it in the oven, bake it for 8 or 10 hours at some 500 degrees or some stupid number, or they got some other way of doing it. I don't know. Maybe somebody out there knows. I'm not a heat treat guy, so I don't know. We're talking a lot of material to weld this thing up. What is that? About 1.5 inches? That'd be a lot of welding. I mean, I got to do more welding anyway. I got to do a bunch of ports and other stuff too, obviously. But anyway, I like the exhaust port, how it comes in a nice good angle. I would like this intake port if it was doing the same thing. See, obviously it's going up pretty good, and then about right here it flattens out to make it package for what they're doing. My packaging is going to be different, so if I can just keep it going straight up, I'll put another half a spacer on here maybe and make it even higher. I'm good with that, because the more you make this thing go straight up and down, the better the ports are going to be, the better it's going to flow air. So I'd rather have this thing up to about here where my thumb is. Would look pretty good. If you watch that curve coming around, it'd be about the height of my thumb right now. Would be a nice even curve coming up. So if I grew the head by another, yeah, like I said, by another spacer, it'll be fine. So anyway, so that's how I like that. These are some rock arms. These are 2-to-1 ratio, so that means if you got a 400 cam, you got 800 lift. So it'd be pretty high. And this motor would need a big motor, big lift like that to make it run. So I would just put something like that in there like this. Now on my head over here, where the intake valve is on this one, it's a real short distance between the push rod and where the valve is. So you would use an automotive rock arm like this in here. On this motor, it would be the exhaust valve. So if you line up your push rod right here, you can see how the tip of the valve is about where the port is. So you could use one of these automotive rock arms like this right here. And all you got to do is weld the bossing right here for the 2 bolts to hold it, and you're done. You don't have to weld up all this other junk. It can be open, it doesn't matter. So we just build that thing up like that. All I got to do is angle it the same angle of the valve, so it would have to be angled like this. The valve stem needs to be perpendicular to this at near half lift, maybe a little below. And so you have that there. So instead of being flat, you would angle it for the Hemi, whatever angle of Hemi you want. I'm thinking something relatively flat, you know, and between 15 and 20 degree angle on each side. I don't know, I haven't decided what I want to do yet. I'm still thinking that in my head. I don't know. I don't have a computer, I have a head. So I just figured out in my brain. So, but anyway, I think this would work pretty good on the exhaust in the back and the intake in the front. And then on the The other valve is going to be way over here, so we'll just use a stock rocker arm over here, but I'll use an Evo style arm. And then we'll angle it to make it work, whatever we need to do. It doesn't matter what angle you make it at, as long as it's perpendicular off that valve. So if you come back at an angle about like this, with the valve put way over here, it would probably work pretty good. Whoop. Get up high enough you can see it. So you want the rocker arm to be over here, so you would, because the push rod's going to be about right here. The tip would be over here, so the arm would go like this, and the automotive arm would be over here. So they both would be kind of going about at angles like this. So anyway, that's how we're looking at doing that, and all this other stuff you just leave in here as is. You cut out where the ports need to be, obviously. So whatever the port comes up in the air, you'll have a big hole going through the head here. This down in here, you would just cut this all away and add fins in there and fill it in. And this would just be fins going all the way across down under here. Except where the bolts would be, you have to put bolt holes up in here, so this would be welded up in here to make it solid. So you can have your bolt holes. So this is a 5-bolt motor here, which is fine. On the bigger bore motors, I'll probably go more like 6 or 8 bolts, especially on the real big motor. So we'll figure that out later. So that's all up in the air. This is a 4-bolt design right here. I think on the other motor, the 4 1/4 bore motor, I'll probably do a double bolt. So I have 8 bolts per cylinder. You know, unless I can find some cylinders. If I find some pre-made cylinders, I'll use those. If not, if I'm going to have cylinders made, I'm going to go to 4 bolts. It's better to have 2 small ones than 1 big one, and the cylinder doesn't get so thick, so cut away in here. So the cylinder's actually thicker, it makes it stronger. So I like that idea better. And so anyway, those are just things that are it's all about a combination of how you go. You got to look at how every piece stacks together on the other piece and make it figure out. And obviously the frame is going to have to be a little bit taller than stock. It's going to go from here to here. So we'll be doing some frame mods. This over here, I think will probably clear the stock single down tube without a problem, because we did kick it this way, which will give us lots of frame clearance. Because normally this gets in the way of the frame right here. With it kicked over like this, we now have a nice open pipe coming out that will not hit the frame. Another reason to do the caulking deal. So it helps the push rod angle, it helps the clearances. On the front motor over here, there's a frame rail over here, but I think this is going to be far enough away that it's going to not hit the frame. It'll clear the frame. You can see it's coming out at a pretty good heavy angle over here. You know, if you have the frame coming down at a Y like the front of the Harley frame is, I think it will clear this one. But who knows? I don't really care. If the frame's in the way, the frame's losing. I'm not changing the motor. So we're going to make the motor make power. We'll figure out how to make it fit in the bike later. So that's how I do things. I don't care about the frame. We'll make them fit. Now on a modified frame, I have to use a stock type frame, or it might even have to be a Harley frame. I'm not sure. I haven't read the rule book lately on that part. I know they don't want you to be raking the thing out or stretching it. I think you can still rake it a few degrees. They kind of don't like you screwing with the head though, but you know, these are Jap bike guys. They don't understand Harleys. Harleys like to chop the front of the frame. Jap bikes, they add longer swing arms. We have rigid frames. We don't change the back. We change the front. So they're stupid. But anyway, the Jap bike guys made the rules, so I got to follow their rules, kind of. So if I rake the front end out a little bit, so you get out to 33 to 35 degrees, you'll be all right. I can't move the neck forward. You know, I don't know if they're going to notice an inch or so. If the motor's hitting the damn frame, it's going to go forward. You know, that's just how it's going to happen. So if they don't like it, oh well. We'll argue. I have safety issues. The frame can't go through the motor. Let them figure it out. So anyway, if I keep the rake down to a minimum, we're all right. I think we're only allowed 10% wheelbase increase. So on a 70, or what's a Harley? 66-inch wheelbase or something. I don't remember. 64. I don't know. I haven't measured a rigid frame lately. So that means you can go about, you know, roughly 6.5 inches longer wheelbase. If you rake it out, you're going to gain 2 or 3 inches there, and I can put 2 or 3 in the back tail. I'm going to use a hardtail. To center the wheel in a hardtail fender, you're going to move it back about 2.5 inches just to get the wheel center in the frame so it looks stock. Even though that's modified, that looks stock. But so I can grow it in the back a little bit. And we keep the frame section through here stock, underneath stock, up the front stock until we hit the frame, we hit the motor. Might have to do a little S like that to clear it. And obviously the backbone cannot be at an angle like this. It's going to have to go like a pro stock bike where it angles up quite a bit. and then back down to the stock neck. So that should make it legal for my frame requirements, but the frame will definitely have to go up high over the motor. Got no options there. So this is all stuff you got to think about, packaging and all that. On a stupid car, you stick the motor in the frame and don't worry about it. But on a bike, it's all out in the wind. You got to figure it into the speed. So you can see how wide the motor would be when you got two carbs sticking out. But you got to remember my legs are right behind it, so my legs are about the same size as a carburetor. So the carburetor is actually be blocking the air for my legs. So aerodynamically, that's helping me, but it's hurting. You still got to cut the same air going down the road, so it's the same aerodynamic load that you got to push through the air with power. It takes horsepower to go through air. But the carburetors are going to be basically what my legs are, so I'll be out of the air, but the carburetors will be in the air, which is good because they're sucking the air. So every cubic foot of air they suck, that's one less cubic foot of air that I have to push out of the way. So bigger carburetors. We like bigger and more flow. That makes me go faster. That's how I look at it. So anyway, that's kind of where I'm at right now. I'm kind of mulling this around in my head on how to do it. I'm going to use the same combination of parts for all three motors. It's just the parts are going to get progressively bigger and bigger and bigger for the bigger motor. So this is going to be a pretty stout little small motor here. This motor with a 4 1/4 stroke with good flowing air heads like these, if I get good ports, you're looking at a 9,000 RPM motor, maybe 9,500. Just like a NASCAR motor, they're turning 10 with these things, so there's no reason why I can't do the same if I got good port flow. They have a little short stroke, though. I'm not sure the NASCAR runs on a cut motor, what stroke they had in them things. I'm guessing probably around 3.5 inches, maybe. I'm running 4 1/4, so my piston speed's a lot higher than theirs, but I have a lot longer rod too, so I don't care. I'm going to spin it. So like I said, if I can get this thing to make power up to around 9, I'll be happy. If it only turns 8, it only turns 8. Oh well. It'll let me know what it likes, and then I'll tell it I want more. And if all else fails, put nitrous on it and some fuel. That'll make it run faster. So anyway, like I said, I like this port design with it going like that. I think the oval port's a good design like this. I think that would work really good on the intake side also. Just bigger and higher up. And I think that would be a good design for me. I don't have the limitation of what the car had because I have a different package. I have other requirements I got to deal with. So, but anyway, that's a nice design. So that's what I'm shooting for. So all you got to remember is we're going to make this here. We're going to make these ports look like that on that. So it'll be a lot of welding, but it's all right. I know how to weld. I have a machine. I know how to use it too. I know how to use both. So there you go. We'll figure it out. And I know how to bolt the motor together, so that takes care of the other problem, making the parts fit. So, all right, well, there you go. That is the plan. And as I go further along, we'll just keep plugging away at this thing. So I got to figure out how to do it in my head, and once I figure out what I want in my head, I'll start cutting some metal out of here. That's why I got these heads to cut up. So we're going to put some big ass holes right through here. So I'm thinking I might just do a preliminary cut, just cut a big pocket right through here, right through the top of the head. Get rid of this rocker box, we don't need it. So just put a big hole right through here like this, and then see what it looks like. Always like just get cut in there and get going. But anyway, that might be the next thing you'll see is a cut up, be some butchered heads. All right, well, that's it for tonight. Get out of here.